Alright guys, so today we're talking about polynomial long division. We're also going to talk about synthetic division, and we're also going to talk about both direct and synthetic substitution. And so we're going to look at these two different methods of substituting values in our equation or into a function first. Okay, so let's say I gave you a question we have an idea how to answer, like find f of -3 if f of x equals this polynomial. Well, what does this mean again? It means to substitute in -3 everywhere we have x. And the method of doing that is called direct substitution. We're just directly substituting in for x. So we'd write our polynomial out. Everywhere we saw x, we'd plug in -3. One word to just be careful with this. So say we were doing specifically this calculation, -3 to the fourth. Be very careful when you put that in your calculator, because if you put it in like this, -3 to the fourth, it's going to give me back an incorrect answer as far as what I wanted. So the calculator is reading this as the opposite of 3 to the fourth. And so it's giving me back -81. When I really wanted the number -3, which we'll need to use parentheses to do this correctly, the number -3 times itself 4 times. And that results in +81. So just be careful, especially when you're plugging in with negative numbers to a power. Make sure you're correctly using parentheses there. All right, so we plug that in. -3 to the fourth is 81. -3 cubed is -27. -3 squared is 9. Okay, so we've done all our exponents. Now we're going to multiply. 2 times 81 is 162. -3 and -27 is 81. 2 times 9 is 18, and then -10. And if we add all these together, we get 251. Okay, so we plugged in -3, and after doing all of this extra calculation, we get our answer of 251. So that does tell me a point on the graph, -3 for x, 251 for y. But there's a faster way of plugging in, and that's this method called synthetic substitution. Okay, so we're going to do the same thing. We're going to plug in -3 into the exact same polynomial. So here's how the setup of synthetic goes, though. We're going to kind of create this little half box in the top left corner, and in that box we're going to put the number we want to plug in. So in this case, -3. Okay, then we're going to look at the highest degree of my polynomial, which is x to the fourth. We're going to set up a placeholder for x to the fourth, x to the third, x to the second, x to the first, all the way down to x to the 0, aka our constant. So that's why I wrote a big C there. And I need to make sure I have a placeholder for all of those. So if I happen to be missing any terms, and in this case we actually did not have an x to the first term, we do need to put a 0 there. And what we're writing down are just the coefficients. So these are the numbers from the front of our variables, right, or the multipliers on our variables. So 2 for x to the fourth, -3 for x squared, for x cubed, 2 for x squared, 0 for that missing x to the first, and that's why I like setting up these labels. That is important. And then -10 for my constant. Okay, so then we leave a line of space. We're going to put some numbers in this row. We'll put kind of like a little total bar here. I like to add an addition sign to remind myself to add things above this line. And we start this algorithm by dropping down the very first number. Okay, so we drop down our first coefficient of 2. And a rule is anything that comes below this line, we're going to multiply by the number in the box. Okay, so 2 times -3, and we write our answer underneath the next number. So we get -6. Okay, and then we're going to add. That's why we put our little addition sign here. We're going to add these two numbers. So that gives us -9, and then we multiply by the number in the box. -3 gives us +27. Adding those together gives us 29. Multiply by the number in the box. This is a little more difficult, but that's -87. Check that with your calculator. Adding that with 0, we get -87. -87 times -3 ends up being 261. And +261 and -10 gives us 251. And hopefully that looks familiar. It's the same answer we got with direct substitution. But this method is much, much faster. It has much smaller number of calculations. I know there's a few big ones at the end, but overall this method is going to save us a lot of time once we learn how to set it up. So again, the number we want to plug in goes in the box. We figure out our highest degree and set up a placeholder from that degree all the way down to x to the 0. Make sure we write our coefficients for each term, keeping the signs of each. And if we're missing any terms, it's really important to put that 0 as a placeholder. We drop down the first coefficient, multiply by the number in the box. That gives us the next number we put under our next coefficient. And then we add. Multiply, add, etc. So it ends up being pretty fast because we're doing our two quickest operations, which usually you can do in your head or faster with the calculator, so multiplying and adding. Okay, let's take a look at our next section, which is going to talk about long division. And so we're just going to kind of do an intro, think about doing the long division algorithm again. So let's say I gave you the top-heavy or improper fraction, 67/5, and I wanted you to write that as a mixed number. So mixed numbers are like, 2 and a third, etc. So that would be an example of a mixed number. Okay, so in order to write this as a mixed number, we need to figure out how many 5s go in there, how many wholes can we make, right? Whole numbers. So we need to divide. And so we got to try to remember some of this division algorithm here. So the first thing we do is we try to figure out how many 5s go into 6. We kind of divide these two. 6 divided by 5. And we can fit 1 5 in there. And then remembering what to do with this 1, we actually multiply it by the 5. So 1 times 5 is 5. And then we needed to subtract. So 6 minus 5 is 1. Trying to remember some of this algorithm, you drop down your next digit. So we drop down our 7. And we basically kind of start over again. How many 5s fit into 17? So 17 divided by 5 is like 3 with something left over, so it goes in 3 times. And we take our 3 and multiply it by 5. So 3 times 5 is 15. And then we subtract. Okay, 17 minus 15 is 2. And here's where we can either put a decimal, we could put a 0 and drop it down and continue if I wanted the decimal. But in this case, to write a mixed number, we don't want the decimals. So we're actually just going to write that 2 as our remainder. Okay, so it tells me we got 13 wholes with 2 fifths left over. So 13 and 2 fifths would be our answer. Now, typically this fraction, and this is correct, really means 13 and 2 fifths. We just don't usually write that plus sign between them, but obviously we're not multiplying them together. But it's 13 and 2 fifths together. And the reason I'm bringing up that there's kind of this hidden plus sign here is because we're going to write polynomials when we divide them when there's a remainder left over in the same exact format. 13 was our answer to our division problem, so that's called the quotient. 2 was our remainder. And 5 is what we were dividing by, and that's called our divisor. So this is our quotient plus remainder over divisor. Actually, I'm going to write remainder over divisor. So this is kind of the format that we used here. And I've written it in some words down here. Quotient plus remainder over divisor. Okay, so we're going to kind of come back to this as we go through our first division problem. Okay, so let's say if I were to multiply two numbers, 13 and 5, and we get the product of 65. Here we could say that we now know 13 and 5 are factors of 65. They're the two numbers we can multiply and get 65. So if I knew 13 times 5 gave me 65, what answer should I get if we divide 65 by 5? We should get 13 back, right? The other factor. So in a similar fashion, let's say if I told you if I multiply these two together, and it gives us this polynomial, x squared plus 8x plus 15. What should I get if I took this polynomial and divided it by x plus 3? We should get back the other factor. We should get back x plus 5. Okay, so just like 13 and 5 are factors of 65, x plus 5 and x plus 3 are factors of this quadratic. So we're going to use that idea to help us in this first one below. And in fact, it's asking me to do this exact problem. Take x squared plus 8x plus 15 and divide it by x plus 3. So what answer should we expect? Well, we should get x plus 5 back. So we should expect to get x plus 5 out of here. And what remainder would we expect to get? Well, let's think about the numbers. If I divided 65 by 5, if 5 is a factor, should we get a remainder? No, we should get a remainder of 0. It should go in perfectly. And since we know x plus 3 is a factor when we divide it, we should get our other factor, and we should get a nice remainder of 0. Okay, so the process here is just like with regular division. It's just like this previous part. All right, so let's try this out. We're going to do x squared and divide by x. We're going to take the largest in each, and we're going to kind of do some division off to the side here. This is why we did some of those exponent rules. So if I have x squared over x, and we need it to simplify, we can cancel one x from the top and bottom, and we get x. So we'd say it goes in x times. And just like when we did in the previous one, remember when we did our regular long division, we're going to multiply this x to the divisor. And in this case, there's two terms, so we do need to kind of distribute it. Okay, so x times x is x squared. We're going to line that up underneath our other x squared. And x times 3 is positive 3x. Okay, so this was the equivalent of, in our previous problem, we multiplied by 5. Right, so we said 5 went into 6 once. We did 1 times 5. We put our 5 down here. And then remember, we need to subtract. Okay, so that's what we need to do next in our problem, is subtract. So I need to subtract this line. And as we've been talking about with polynomials, when we subtract, we want to do that as the same as adding the opposite. Let's change this to plus. We're going to make that minus and that minus. Okay, so when we add the opposite here, these cancel out. We end up here with positive 5x. And then we're going to drop down the rest of our polynomial plus 15. Okay, so if we go back here, it's just like when we subtracted, we got the 1, we dropped down our 7, and now we basically start over again. Okay, so going back to this, now I want to take the largest term in each, sorry about that, the largest term in each, 5x and x, and divide them off to the side. 5x divided by x. We can cancel out those x's, and we get positive 5. Okay, so now we need to take our 5, multiply them over here. 5 times x gives us 5x, and 5 times 3 gives us 15. But remember, we need to subtract this answer. We need to subtract that whole thing. We're going to do that by adding, which that would stop changing, there we go, adding the opposites. Okay, so when we do that, those cancel out, these end up canceling out, and that tells me we get a remainder of 0. So my answer is x plus 5 with no remainder. And that's what we're expecting, right? X plus 5 with the remainder of 0. And if the remainder is 0, you don't need to do the plus the remainder over the divisor part, we can just say we got a nice perfect product, and it's x plus 5. All right, so let's try another example. I know that maybe that was a little confusing. Hopefully not too confusing. It is the same algorithm we normally use when we divide. Okay, let's try another one. Okay, so let's say, again, let's take the largest term in each, x squared divided by x. And really, before we get into this, notice this is the same polynomial we just divided, but now we're dividing it by x minus 2, which was not one of its two factors. So what do you think that means about our remainder this time? Means we're probably getting a remainder, right? It's not going to be 0. So let's try this. We're going to take x squared and divide it by x. Again, the largest term in each. We're just going to do that kind of off to the side here. X squared divided by x goes in x times. So write our x up here. Now we need to distribute our x. So x times x is x squared. We'll line that up underneath my x squared. And x times negative 2 is negative 2x. And remember, we need to subtract this whole line. So we're going to put minus parentheses, because it is minus all parts there. And we're going to do that again by adding the opposites. So make that plus instead of minus 2x. All right, so we're going to combine these. These cancel out. These end up giving me 10x, 8x, and 2x. And we'll drop down our plus 15. Okay, then we basically start again. 10x divided by x. Okay, we can cancel one x from the top and bottom, and we're left with positive 10. So plus 10. Okay, distributing our 10, 10 times x is 10x, and 10 times negative 2 is negative 20. And you remember, again, I need to subtract this line, and it's all terms, so we need those parentheses. And we're going to do this by adding the opposites. Okay, so the 10x is canceled, but I end up getting positive 35. And I'll know I'm at my remainder if in my divisor, or sorry, in my quotient, I should say, we were already at the constant. And or if you did try to divide again, if you have more x's in the bottom than you have up top, we've gone too far. Okay, so that won't work. So this tells me we get a remainder of 35. And so this is where we're going to write our answer in the form, the quotient plus the remainder over the divisor. So when we write our final answer here, we can write it as x plus 10 plus our remainder, so we're going to create a fraction, 35, over the divisor, what we were dividing by, x minus 2. And that's how we'd write our answer if it has a remainder. Okay, so if you want to pause the video now, there's a third example in your notes to try out. Try that out and see what you get. All right, hopefully, if you did it right, I think it's 2x plus 3, if memory serves me right, with no remainder. If you didn't get that, you might want to go back and rewatch the video to hopefully figure it out. Okay, let's try this next example. And I know there was a typo on my sheet this year. This was accidentally a 15. Change it back to an 18 like it should have been. I know the questions here are slightly different as well because I don't know what I was thinking, but change this to an 18. That's what we really should have here. So we're going to do one more polynomial division. We're going to take this guy and this, and again we're going to do our division off to the side. 2x cubed divided by 2x squared. Well, the 2's will reduce to a 1, and we can cancel two sets of x's between the top and bottom. And we end up with just x. So now we need to distribute our x to 3 different terms. But that's okay, we're just multiplying by x, they're all just going to get an extra x, right? So we're going to get 2x cubed minus 5x squared, again lining these up underneath their like terms, and x times 3 is positive 3x. But we need to subtract this whole line by adding the opposites. Okay, so these cancel out. Whoa, that's not where I wanted that. Those cancel out. We get negative 6x squared plus 15x, and we're going to drop down our minus 9. Okay, and we basically start over. Great time for my phone to go off. Next, let's divide negative 6x squared and 2x squared. Well, the x squareds will cancel each other out, and we get negative 3. So minus 3. Distribute our negative 3 to all three parts. I know it's getting pretty messy up here. Negative 3 times 2x squared is negative 6x squared. Negative 3 times negative 5x is positive 15x. And negative 3 times 3 is negative 9. And I want to subtract all of that. And again, we're going to do it by adding the opposites. That's now a plus. So that cancels. Hey, those cancel and those cancel, which tells me we get a nice remainder of 0. So what does it mean that we got a remainder of 0? I mean, it went in perfectly, right? So x minus 3. I guess it really tells me, sorry, that 2x squared minus 5x plus 3 divides it nicely. Divides, wow, nicely. What does that tell us specifically about 2x squared minus 5x plus 3 and x minus 3? Well, remember, if we got a remainder of 0, that meant that it's a factor. And in fact, not only is 2x squared minus 5x plus 3 a factor, we found its other factor with division. So they are factors of 2x cubed minus 11x squared plus 18x minus 9. So they're factors. Those are our two factors. We can multiply and make that polynomial. And later on, we'll use that to help us find our zeros. Okay, we got one last part on our note sheet here, which is talking about synthetic division. So that same synthetic algorithm we did earlier, we can use actually to divide in some cases. So if our divisor is a linear binomial, dang it, did it again, linear binomial, so that means it's x to the first power is our highest degree, and it has two terms. And its coefficient has to be a 1. So 1x to the first, plus or minus some whole number. Okay, so if we're dividing in with these kind of specific looking cases, then we can use synthetic division. And it uses this algorithm that looks just like synthetic substitution. The only difference is, by the way, if you look at the previous problem, let's say we wanted to divide this polynomial, which is what we did in the last example, and divide it by the answer we got, x minus 3. What should my answer be? Well, I think we should get 2x squared minus 5x plus 3. And what would our remainder be? It should be 0, right? Okay, so I'm going to show you this process with synthetic. All right. The first thing we need to do, though, is we need to take our divisor and set it equal to 0 and solve. We need to find its 0. So if you set this equal to 0, I'd have to just add 3 over, and we get positive 3. Okay. This is called the 0 over divisor, and that's the number we put in the box. So it's the only thing that's different. We're not plugging in 3, we're dividing by x minus 3. Okay. So we take our original coefficient, again, x to the third is the highest degree, so we put a placeholder for x to the third, x to the second, x to the first, down to the constant. And we write in our coefficients, 2, negative 11, 18, negative 9. We weren't missing any, so we didn't need any zeros for placeholders. Okay, then we drop down our first coefficient of 2 to get us started. And if you remember from the beginning of the video, we're going to multiply by the number in the box with anything below this line. So 2 times 3 is 6, and then we're going to add, which gives us negative 5. Negative 5 times 3 is negative 15. When I add, we get positive 3. And 3 times 3 is 9. When I add, we get 0. And so if you look at these numbers, 2, negative 5, 3, 0, and look at what we're expecting our answer to be, 2x squared, negative 5x, plus 3 with the remainder of 0, we can see all those numbers right here. And in fact, this last calculation tells me the remainder. The number just to the left of it will always be our constant, or x to the 0. This is the coefficient of x to the first. This is the coefficient of x squared. If there was another number, this would be the coefficient of x cubed, another one x to the fourth, etc. But this last number, it's always the remainder, constant, x to the first, x to the second, etc. Okay, obviously we don't really have an x to the third term. That was just to cover some other cases. So as we write our answer, it's 2x squared minus 5x plus 3 with no remainder. And that's what we expected to get when we divided by the other known factor, x minus 3. Okay, so let's try one last example. I know this has taken a while. Okay, this is a good candidate again for synthetic. It's 1x to the first power plus or minus a nice whole number. Okay, so remember the first thing we got to do though is take our divisor over here and find its 0. So if I add 1, x has to equal positive 1. That's the number that goes in our box. And I'll put a plus sign just for emphasis. Okay, so x cubed is my highest degree. We'll set up a placeholder for x cubed, x squared, x to the first, all the way down to x to the 0, aka our constant. And we'll write in our coefficients. We've got a 1, x cubed, negative 4, x squared, positive 2x, and positive 7. We'll leave one line of space and put our plus sign, and then drop down our first coefficient. Okay, 1 times 1 is 1. And then when we add, we get negative 3. Negative 3 times 1 is negative 3. When I add, we get negative 1. Negative 1 times 1 is negative 1. When we add, we get 6. And so this 6 is my remainder. So that tells me it did not divide nicely. X minus 1 is not a factor, but we can still write our answer. Okay, remember that this is our constant, x to the 0, or the constant. This next number is x to the first, and this is x squared. So writing our answer, I'll try to squeeze it in over here. We have 1x squared minus 3x. Oh, I'm not going to have space here. Hang on. We'll squeeze in the very bottom. Sorry. Maybe we'll write it up here. We'll write it up here so you can see it better. X squared, 1x squared, minus 3x, minus 1, plus our remainder over the divisor, which was x minus 1. And there it is. There's our answer to that second example. Okay, try some in your homework. Ask people in your group. Rewatch the video if you need to.